Vitamin B6, often relegated to the background of nutritional discourse, plays a quietly powerful role in protecting against colorectal cancer, one of the most common and deadly malignancies worldwide. While mainstream cancer prevention guidelines focus heavily on lifestyle factors such as fiber intake, red meat reduction, and colonoscopy screening, the critical role of B6 in DNA synthesis, repair, and methylation is rarely acknowledged. Yet, the epidemiological and mechanistic evidence connecting B6 status to colorectal cancer risk is not only compelling, it suggests a major oversight in modern preventive strategy. At the biochemical level, B6 is a coenzyme for numerous reactions involved in one-carbon metabolism, a process central to maintaining genomic stability. It works closely with folate and vitamin B12 to regulate methylation pathways, which are essential for proper DNA replication and gene expression. When methylation is disrupted due to low B6 or folate/B12, DNA becomes more susceptible to abnormal expression and damage, laying the groundwork for mutations and malignancies. In colon tissue, where cells turn over rapidly and are exposed to potential carcinogens from the diet and gut microbiota, this vulnerability is especially dangerous. One of the key protective roles of B6 is its involvement in converting homocysteine, a potentially toxic metabolite, into cysteine through the transsulfuration pathway. Elevated homocysteine is not only a cardiovascular risk marker, but also a pro-inflammatory compound that can damage vascular and epithelial tissue. In the colon, excess homocysteine can contribute to oxidative stress, impair DNA repair mechanisms, and support a microenvironment conducive to tumor growth. Adequate B6 helps keep homocysteine in check, reducing inflammation and supporting a more stable epigenetic profile in the cells lining the intestinal tract. Several large-scale epidemiological studies have drawn strong associations between higher B6 intake or blood levels and a lower risk of colorectal cancer. For example, a meta-analysis of prospective studies published in JAMA found that individuals with the highest levels of vitamin B6 had a significantly reduced risk of colorectal cancer compared to those with the lowest levels. Another study in gastroenterology reported that higher PLP, active B6, plasma concentrations were inversely associated with colon cancer incidence, even after adjusting for confounding factors such as age, smoking, alcohol, and folate intake. These associations are not merely statistical artifacts, they make biological sense. DNA methylation, nucleotide synthesis, and inflammation control are all deeply dependent on B6. Animal studies have shown that B6-deficient diets increase rates of DNA strand breaks and chromosomal instability in colon cells. This suggests that B6 insufficiency may not just permit cancer to grow, it may help initiate it. Yet despite this growing body of evidence, vitamin B6 remains conspicuously absent from most official cancer prevention guidelines. Organizations like the American Cancer Society or World Health Organization prioritize general dietary patterns and physical activity, but rarely highlight individual micronutrients unless tied to major public awareness campaigns like folate and neural tube defects. B6, lacking that kind of visibility, is lost in the shuffle. Even nutrition panels used in routine checkups do not screen for PLP levels, meaning at-risk individuals may live for years with subclinical B6 deficiency, never knowing their colon health is being compromised from the inside out. Another factor contributing to B6's invisibility is the misconception that deficiency is rare in developed nations. Technically, overt deficiency is uncommon, but functional deficiency, where blood levels appear normal but tissue levels are inadequate for optimal enzymatic activity, is much more prevalent, especially among older adults, people with high stress levels, chronic inflammation, or those taking medications like metformin, proton pump inhibitors, and oral contraceptives. These individuals are precisely the ones who may also be at elevated risk for colorectal cancer, compounding the threat. Moreover, dietary surveys show that many people do not meet even the modest recommended dietary allowance, RDA, for B6, particularly those consuming processed foods or limited animal products. And unlike folate, which is fortified in flour and cereals, B6 is not widely added to processed food. This silent inadequacy persists undetected while the public is told they're getting enough from their diet, leading to a false sense of security. In terms of prevention, supplementation with B6, particularly in its active form, P5P, offers a low-cost, low-risk strategy to support colon health. While the exact therapeutic dose for cancer prevention isn't standardized, Intakes in the range of 10 to 50 milligrams per day have been shown to elevate PLP levels significantly and safely. These levels support methylation, antioxidant capacity, and proper cell cycle regulation, all critical in the battle against cellular mutation. In conclusion, vitamin B6 has all the characteristics of a key anti-cancer nutrient: biologically necessary, mechanistically sound, epidemiologically supported, and tragically underutilized. Its absence from cancer prevention discourse is not just an oversight, it's a public health failure. For a nutrient so integral to DNA integrity, inflammation control, and detoxification pathways, its neglect in colorectal cancer strategies is both ironic and dangerous. Raising awareness of B6's role in cancer prevention, especially colorectal cancer, could be a powerful, evidence-based step toward reducing incidence in a population increasingly threatened by lifestyle-related malignancies. It's time to put this silent guardian back on the radar.